The next chapter is Material Requirements Planning, also known as MRP. And ERP is Enterprise Resource Planning, which is an extension of MRP. Now we're going to talk about dependent demand items and dependent demand inventory model requirements. What are the requirements for the modeling? And the MRP, Material Requirements Planning structure, how it is done, and how it is managed, MRP management. Then we'll also talk about lot sizing techniques and some concepts related to extensions of MRP and MRP in process and ERP. So these are the topics that we'll be covering in this chapter. Now we'll start with dependent demand inventory items. We talked about dependent demand and independent demand in chapter 12. Independent demand items are the finished products that we sell to the customers, and the demand for those products are independent of production decisions, and that's the reason why they are called independent demand items. And the inventory models for independent demand items were discussed in chapter 12. In this chapter we're going to talk about the models required for, or models that can be applied for, dependent demand items. And the dependent demand items are items whose demand is dependent upon the schedule of other items. So one way of looking at it is the items required for the production of the final product. And also we can look at dependent demand items as items whose production we schedule based on the production of some other item. You can look at it in that fashion. So scheduling of this item is dependent upon the schedule of some other item. So demand for one item is related to the demand of another item. So that's what makes a given item a dependent demand item. So given a quantity of the end item, then the demand for all the parts and components needed for the production of the end item can be calculated both in terms of quantity and in terms of timing. And that's the feature of dependent demand items. And that's the reason why we have to look at modeling for dependent demand items in a different way than what we covered in chapter 12. So in general, it is used whenever a schedule can be established for an item, and MRP is the common technique that we use, material requirements planning. And that is the modeling technique we'll be using for dependent demand items. Now what are the benefits of using this MRP approach or MRP modeling for dependent demand items? Well, you will be able to produce your parts at the right time in the right quantity, and therefore you will be able to fulfill customer orders as promised. So better response to customers and faster response to market changes, because you have an established system that can adjust to changing market conditions. And you'll also be able to predict what capacity needs will be, so we can fine-tune the capacity availabilities, so we can improve the utilization of facilities and improve the utilization of labor. And most importantly, you can keep the inventory levels low, reduce inventory levels, because you can precisely compute the quantity needed and when they are needed. The timing and quantity can be very precisely calculated, and because of that we can keep inventories low, because we can time it exactly as to when they will be required. Now, effective use of this MRP approach, the dependent demand inventory models, the MRP approach requires, these are the prerequisites for the MRP to make the computations of an MRP modeling approach. And there are 5 prerequisites. Of these, the first 2 are new concepts for students: master production schedule and bill of materials. We'll talk more about that in detail in just a few minutes. The last 3 are readily understandable: inventory availability, how much inventory do we have in stock. 4th item is purchase orders outstanding, the orders that have already been placed and we have a promised delivery date. So these are called scheduled receipts. So these inventories are not physically available in stock, but there is a vendor commitment as to when those quantities will be available. And fifth item is the lead time of production. For a given item, when you place an order with the shop floor or with a vendor, how long is it going to take for that order to be fulfilled? So that's your lead time. So these 5 items are needed. We'll talk more about master production schedule and bill of materials. And these 5 are prerequisites for the MRP computations to be completed successfully. Now let's talk about master production schedule, the first prerequisite that we saw in the previous slide. Now it specifies what is to be made and when it is to be made for the independent demand items. So master production schedule is a production schedule of the end item, the final item that we sell to our customers. So this is your independent demand items. So you need to have a schedule of how many units and when those items will be produced, and that's your master production schedule. And it must be, the master production schedule quantities must be such that they are consistent with the aggregate planning document, the aggregate production plan that we talked about in the previous chapter 13. So if the aggregate plan calls for an overall production of 1,000 units, and your master production schedule, which is for individual products, when you combine them all, it should be 1,000. It shouldn't be less than 1,000, it should be more than 1,000, so that it must have a direct connection between, the master production schedule should have a direct connection to aggregate production plan. And when we develop the master production schedule, we need to get input from other functional areas so that our master production schedule reflects the plan of other functional areas like financial plans. You need to make sure that the financial plan and the master production plan are consistent. And similarly, customer demand. You can't have a master production schedule that is out of whack from customer demand, in which case you will be producing something that the customers don't want, or the quantities and timing of your production does not match with customer demand. Engineering is if there are design changes made to the product, and that should be taken into account in developing a master production schedule. And supplier performance is also very important, because if you have a master production schedule that cannot be implemented because your vendors, your suppliers are not able to meet the components and parts requirement of a master production schedule, then you will not be able to fulfill or implement the master production schedule. So you have to get inputs from all of these different areas and incorporate that into your master production schedule process. So as the process moves forward from the planning stage to the implementation stage, at every step of the way you have to calculate the capacity required, the financial resources required, the labor resources required, make sure it is feasible. So feasibility should be checked every step of the way. So master production schedule is the result of this production planning process. Master production schedule is established in terms of specific products, and I just talked about that. The schedule must be followed for a reasonable length of time. So usually it will be like on a weekly basis for about 10 weeks or 13 weeks. So about 1 quarter, I would say, broken down in weekly, what we call as time buckets. Now, in the new developments in the master production schedule and MRP technology has made it possible to even reduce the time buckets from weekly time buckets to even daily time buckets. And we'll talk about that a little later. So MPS is often frozen or fixed in the near term of the plan. So if you have a master production schedule of 13 weeks, the first 3 or 4 weeks of the master production schedule will be frozen. Frozen meaning you cannot make changes to the quantities of those first few weeks. The reason for that is if you allow changes in the first few weeks, those changes will snowball down into a lot of changes in the shop floor activities, and people will have no faith in the actual plans that are being implemented, because it keeps changing all the time. And this is called system nervousness. Small changes at the top will make a lot of changes at the bottom. So to avoid this system nervousness, you will freeze the first few weeks, 2, 3, 4, 5 weeks of master production schedule, and no changes are allowed in those weeks. And beyond that, changes can be made based on demand forecast changes or capacity requirement changes and so on. Master production schedule is a rolling schedule, meaning as you move through time, so when the first week in the master production schedule becomes past week, one additional week is added at the far end. So you'll always have like 10 or 13 or 15 weeks, and it's a rolling plan. Master production schedule is a statement of what is to be produced, and it is not what the forecasted demand is. Of course, the master production schedule should be able to meet the forecasted demand, but the MPS itself is not a forecast. It is a production statement, a statement of production quantities. So here is the planning process and where the master production schedule fits in. So this is where the master production schedule is. So the top sits the various functional area medium term plans, like 1 year to 18 months. And then from master production schedule down below is your MRP, material requirements plan. So let's look at it more closely. So the top part, we have various long range plans, out of which aggregate planning is one. So this is your sales and operations planning and aggregate plan, which we discussed in the previous chapter, and that drives your master production schedule. So there must be total consistency between these two. Then below master production schedule is your MRP. Master production schedule drives the MRP computations. So to meet the master production schedule, what are the dependent demand items that are required, and when are they required, in what quantity? And if there are any inconsistencies or capacity problems, then the master production schedule has to be changed to make sure that it is feasible, and the material requirements plan that we develop is feasible. And material requirements plan then drives your schedules, and we'll talk about scheduling in the next chapter. So here is an example of how the MPS, master production schedule, and aggregate plan must be consistent. So here we are talking about a company that makes amplifiers, and let's assume that they make 3 different amplifiers. Now when we develop aggregate plan, we have to combine these 3 into an aggregate product, and we have an aggregate plan. And let's assume that we make the aggregate plan on a monthly basis. So let's suppose that the aggregate plan calls for a total production of 1500 in January, 1200 in February, and so on. Now when you break that down into the master production schedule level, now you have production quantities for the actual individual products. And you see, when you sum the products scheduled for the weeks in January, they total up to the aggregate production quantity. Same here for February. You take the individual order quantities, production order quantities for the individual products, sum them, and that is equal to the aggregate production quantity for February. So there must be total consistency between the aggregate plan and the master production schedule. The master production schedule can be made in 3 different environments. One is called make to order, where production takes place only after a customer order is received. So in those cases, the customer orders will go into your master production schedule. And the third scenario is stock to forecast, where you produce ahead of customer demand based on forecast and keep it in stock, and when customers order, then you immediately deliver the product based on customer orders. In these cases, you will look at the end items, and the end item quantities will go into your master production schedule. And there is what is called assemble to order environment, where when you have lots of different products that can be made from a few sub-assemblies. The master production schedule in these cases will be made for the sub-assemblies, so which are called modules. So assemble to order. So you will produce these modules based on master production schedule, and then as the customer order comes in, you will put together these modules in whatever combination that is necessary to produce the final products. So this is called assemble to order, and produce to modules, and the modules are then assembled to order. So here is an example of a master production schedule, and this one is made on a daily basis, and you will have quantities of how much to be made.